Module 6, Part 3, Hypothesis Testing. We'll now turn our attention to explaining Type 1 and Type 2 errors. A legal analogy of hypothesis testing. In American courts of law, the fundamental principle is that a defendant is presumed innocent until proven guilty. Because the starting assumption is innocence, this represents the null hypothesis. So the null hypothesis would be the defendant is innocent, and the alternative hypothesis is the defendant is guilty. The job of the prosecutor is to present evidence so compelling that the jury is persuaded to reject the null hypothesis and find the defendant guilty. If the prosecutor does not make a sufficiently compelling case, then the jury will not reject the null hypothesis and the defendant will be found not guilty. Type 1 error. In the physician's reaction case study, the probability value associated with the significance test is 0.0057. Therefore, the null hypothesis was rejected and it was concluded that the physicians intend to spend less time with obese patients. Despite the low probability value, it is possible that the null hypothesis of no true difference between obese and average weight patients is true and that the large difference between sample means occurred by chance. If this is the case, then the conclusion that physicians intended to spend less time with obese patients is in error. This type of error is called a Type 1 error. More generally, a Type 1 error occurs when the significance test results in the rejection of a true null hypothesis. By one common convention, if the probability value is below 0.05, then the null hypothesis is rejected. Another convention, although slightly less common, is to reject the null hypothesis if the probability value is below 0.01. The threshold for rejecting the null hypothesis is called the alpha level, or simply alpha. It is also called the significance level. As discussed in the introduction to hypothesis testing, it is better to interpret the probability value as an indication of the weight of evidence against the null hypothesis than as part of a decision rule for making a reject or do not reject decision. Therefore, keep in mind that rejecting the null hypothesis is not an all or nothing decision. That is why current research generally reports the probability or p-value so that the reader can decide how compelling the evidence to reject or fail to reject the null hypothesis is. In the past, research simply reported the significance level and the decision without reporting the actual p-value. As discussed earlier, this method left the reader with no sense of how close the decision actually was. As you read studies and see p equals, you now know that this is telling you the probability that the effect could have occurred by chance alone. The smaller that value, the more likely it is that the observed effect was not due to chance alone and hence might be due to what the researcher is hypothesizing. Statisticians consider values less than 0.05 small enough to merit consideration. This would correspond to a confidence level of 95%, which we've discussed earlier. The p-values are probabilities, so they will always be decimal values less than 1. You might think a number like 0.3 is a pretty small number, but not when you consider that p-values will always be less than 1. Now you know to look for p-values less than 0.05 when you read a research study. The Type 1 error rate is affected by the alpha level. The lower the alpha level, the lower the Type 1 error rate. It might seem that alpha is the probability of a Type 1 error. However, this is not correct. Instead, alpha is the probability of a Type 1 error given that the null hypothesis is true. If the null hypothesis is false, then it is impossible to make a Type 1 error. There are 4 outcomes from hypothesis testing. You could reject the null hypothesis when the alternative hypothesis is true. That would be a correct decision. That's what you want to do. Another outcome would be that we don't reject the null hypothesis when the null hypothesis is true. This decision would also be correct. If the null hypothesis is true, then we certainly don't want to reject it. The third possibility is that we reject the null hypothesis when the null hypothesis is true. This decision would be incorrect. If the null hypothesis is true, then we don't want to be rejecting it. If we do that, though, this type of error is called a Type 1 error. And the fourth possibility is that we do not reject the null hypothesis when the alternative hypothesis is true. This decision would be incorrect, and this would be called a type 2 error. This is just a table that condenses the four possible outcomes in hypothesis testing. Type 2 error. The second type of error that can be made in significance testing is failing to reject a false null hypothesis. This kind of error is called a type 2 error. Unlike a type 1 error, a type 2 error is not really an error. When a statistical test is not significant, it means that the data do not provide strong enough evidence that the null hypothesis is false. Lack of significance does not support the conclusion that the null hypothesis is true. Therefore, a researcher would not make the mistake of incorrectly concluding that the null hypothesis is true when a statistical test was not significant. Instead, the researcher would consider the test inconclusive. Contrast this with a type 1 error in which the researcher erroneously concludes that the null hypothesis is false when in fact it is true. A type 2 error can only occur if the null hypothesis is actually false. For each of the following claims, explain what it would mean to make a type 1 error. What would it mean to make a type 2 error? Stop the video and consider these questions before looking at the solution on the next slide. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes this percentage is different today. A type 1 error would be made if the researcher concludes that the population proportion does not equal 62% or 0.62 when the true population of Americans 18 years or older who participated in some form of charity work is currently 0.62 or 62%. A type 2 error would be made if the sample evidence leads the researcher to believe that the current percentage of Americans 18 years or older who participated in some form of charity work is still 62%, when in fact this percentage differs from 62%. Part B. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. A type 1 error would occur if the sample evidence leads the researcher to conclude that the population mean length for a cell phone call is greater than 3.25 when in fact the actual mean call length on a cell phone is still 3.25 minutes. A type 2 error occurs if the researcher fails to reject the hypothesis that the mean length of a phone call on a cell phone is 3.25 minutes when in fact it is longer than 3.25 minutes. So alpha is the probability that we make a type 1 error, which is rejecting a null hypothesis when the null hypothesis is in fact true. This would be like sending an innocent person to prison. Beta is the symbol we used for the probability of a type 2 error, which would be not rejecting the null hypothesis when the alternative hypothesis is true. This would be like setting a guilty person free. The probability of making a type 1 error, alpha, is chosen by the researcher before the sample data is collected. The level of significance, or alpha, is the probability of making a type 1 error given the null hypothesis is true. As the probability of a type 1 error increases, the probability of a type 2 error decreases, and vice versa. So you can't change one without changing the other. It's a balancing act. The probability of making a type 1 error and making a type 2 error are called dependent events. When one goes up, the other goes down, so you can't change one without affecting the other. Question. It has been shown many times that on certain memory tests, recognition is substantially better than recall. That's why students would rather have a multiple choice test than a fill-in-the-blank test. However, the probability value for the data from your sample was 0.12. Since that value is bigger than 0.05, you are unable to reject the null hypothesis that recall and recognition produce the same results. What type of error did you make? Stop the video and answer the question before looking at the solution on the next slide. In this example, there is really a difference in the population between recognition and recall, but you did not find a significant difference in your sample. Failing to reject the false null hypothesis is a type 2 error. In the population, there is no difference between men and women on a certain test. However, you find a difference in your sample. The probability value for the data was 0.03, that's less than 0.05, so you rejected the null hypothesis. What type of error did you make? Stop the video and answer the question before looking at the solution on the next slide. There is no difference in the population, but you found a difference in your sample. A type 1 error occurs when a significance test results in the rejection of a true null hypothesis. As the alpha level gets lower, which error rate also gets lower? Stop the video and answer the question before looking at the solution on the next slide. The type 1 error rate is affected by the alpha level. The lower the alpha level is, the lower the type 1 error rate gets. Alpha is the probability of a type 1 error given that the null hypothesis is true. The null hypothesis is false. You cannot make which kind of error? Stop the video and answer the question before looking at the solution on the next slide. A type 1 error occurs when a significance test results in the rejection of a true null hypothesis. If the null hypothesis is false, it is not possible to make a type 1 error. According to Giving and Volunteering in the United States, 2001 edition, the mean charitable contribution per household in the United States in 2000 was $1,623. A researcher believes that the level of giving has changed since then. Determine the null and alternative hypotheses, and then explain what it would mean to make a type 1 error and a type 2 error. Stop the video and work this problem before looking at the solution on the next slide. Your null hypothesis would be that the mean is equal to $1,623. Your alternative hypothesis would be that the population mean does not equal $1,623. The alternative hypothesis is not equal because no direction of change is given. The researcher feels the level is different, but he doesn't state whether it would be an increase or a decrease. If you make a type 1 error, the sample evidence would lead you to reject the null hypothesis and conclude that the mean charitable contribution per household in the U.S. is not $1,623, when in fact it actually is $1,623. You would make a type 2 error if you do not reject the null hypothesis that the mean charitable contribution is $1,623, when in fact it is different than $1,623. Fair packaging and labeling. Federal law requires that a jar of peanut butter that is labeled as containing 32 ounces must contain at least 32 ounces. A consumer advocate feels that a certain peanut butter manufacturer is shorting customers by underfilling jars. Determine the null and alternative hypotheses and explain what it would mean to make both a type 1 and a type 2 error. Stop the video and work the problem before looking at the solution on the next slide. So the null hypothesis here is that the mean is 32 ounces, and the alternative would be that the mean is less than 32. The alternative is less than because the consumer advocate believes the mean weight of the jars is less than stated on the label. You'd make a type 1 error if the sample evidence leads you to reject the null hypothesis and conclude that the mean weight of the jars is less than 32 ounces, when in fact the true weight is 32 ounces. You'd make a type 2 error if you do not reject the null hypothesis that the mean weight of the jars is 32 ounces, when in fact the true mean weight is less than 32 ounces. According to the Centers for Disease Control and Prevention, 16% of children aged 6 to 11 years old are overweight. A school nurse thinks that the percentage of 6 to 11-year-olds who are overweight is higher in her school district. Again, determine the null and alternative hypotheses and what it would mean to make both type 1 and type 2 errors. Stop the video until you work the problem and then look at the solution on the next slide. So your null here would be that the true population proportion is 16% or 0.16, and your alternative would be that that proportion is greater than 0.16. It's greater than because the school nurse believes that the percentage of 6 to 11-year-olds who are overweight is higher than 16%. You would make a type 1 error if the sample evidence leads you to reject the null and conclude that the proportion of 6 to 11-year-olds who are overweight is higher than 16%, when in fact it is actually equal to 16%. You would make a type 2 error if you do not reject the null hypothesis that the proportion of 6 to 11-year-olds who are overweight is 0.16, when in fact it's more than 0.16. Now, the interesting thing about all of this, they're hypothesis tests, and we never really know what the truth is. Now take the Module 6 Part 3 Assessment of Learning. The password is errors in all lowercase.